In 2026, the hard technology sector is undergoing some historic changes. Oh, well, in the past few years, artificial intelligence, robotics, computing infrastructure, and 3D printing have all been hot topics, but very few technologies have actually moved from concept to large-scale production and created real industrial impact. This year, however, a few events suggest a turning point. The most notable is Elon Musk's i5 chip completing tape-out 45 days ahead of schedule. This isn't just a milestone on paper. It means humanoid robot production can accelerate significantly, giving real momentum to the Artemis project. Meanwhile, AI computing infrastructure is advancing rapidly, including breakthroughs in liquid cooling technology that allow massive computing units to run stably, and diamond heat dissipation that surpasses copper by more than 5 times, which is critical for cooling high-density chips in data centers. Even space-based computing is entering the conversation on deploying data centers in low Earth orbit to explore entirely new combinations of computing power and latency. All these technologies, while seemingly unrelated, point to the same underlying logic, pushing computing limits, improving efficiency, and enabling scalable applications. Beyond computing, advanced manufacturing is quietly transforming traditional industry. 3D printing is moving from prototyping to mass production in areas like the watch components and rocket engine parts. The semiconductor supply chain is simultaneously adapting with improvements in PCB drilling accuracy, high performance optical modules, HBM memory with higher bandwidth, and nickel components like planetary roller screws and Davis double-click system. Taken together, these developments show that investing in hard tech is no longer about chasing hype or hot concepts. It's about focusing on technologies that can achieve scale and practical application. There are 4 high-certainty sectors emerging. First, humanoid robots and related hardware, including AI chips, sensors, and integrated electromechanical systems. Second, AI computing infrastructure optimization, including liquid cooling, heat dissipation, and space-based computing solutions. Third, advanced manufacturing, particularly high-precision, high-performance 3D printing. The semiconductor and critical component supply chain, including domestic alternatives and technical upgrades across PCBs, optical modules, HBM, and precision mechanical parts. The common thread is that only technology is capable of scalable production and practical application while improving efficiency can generate 10-bagger potential. Short-term market hype or conceptual buzz rarely delivers that kind of value. Observing these sectors, production capability is the most critical metric. It outweighs any marketing claims. In 2026, hard tech investing is increasingly about closing the loop from lab to industrial application. Capital and resources are flowing for technologies that can be realized, not just conceptual trends. In humanoid robotics and AI infrastructure, breakthroughs, and early production provide a clear competitive edge. At the same time, 3D printing and advanced e-manufacturing are penetrating multiple industries from consumer electronics ICs to aerospace, driving new business models. Semiconductor supply chain P-grade support domestic demand and play a key role in global industry competition. Taken together, these factors outline a clear investment approach. Focus on technologies that can scale and be applied. Track progress in full. National innovations in supply chain readiness and monitor milestones. Chip, tape, out, robot production, deployed cooling solutions, and 3D printing in mass production. This approach allows investors to identify trends and opportunities without being swayed by short-term market noise. Though logic emphasizes certainty and practical application, defining the 2026 Tech investment frontier. Both institutional and retail investors can use this framework to identify high-value sectors and seize opportunities they'll drive real industrial transformation and capital gains.